So 410 notes for transforming linear functions. Our objective today is to describe how to change slope and y-intercept, how changing them, affect the graph of the linear function. So what are we going to do if the b value changes? Alright, so first thing we're going to talk about is a family of functions. Families of functions have certain characteristics, common characteristics, common shapes, common, it's a family. So the example that we'll use with this is that all linear functions form a family because their graphs are the same basic straight line shape, right? So same basic shape as straight line. Quadratics, for instance, there's a family of quadratic equations because they all kind of have this rounded shape. So that's how we kind of identify a family in math functions. Alright, then within your family function you do in fact have a parent function. This is the most basic function in the family, so notice for linear functions the parent function is y equals x. If we associate that with y equals mx plus b, we're saying that m is 1 times x will still be x, and b is 0. So just kind of identifying that idea. And then your transformation is a change in position or size of a figure. So that transformation then kind of makes a kid versus a parent function. Alright, so looking at some images here. There are three types of transformations, and the transformations are translations, which is what we're seeing here, rotations, which we're seeing here. Notice it's kind of centered on this 0, 0, and then also reflections. So we take our one equation and reflect it across the y-axis, for instance. Alright. So, next piece is defining a translation, just being very specific. So translation is a type of transformation. So issue with this is that transformation looks very much like translation. So just know that translation, a lot of people look at this SL and kind of identify it as a slide, versus a transformation is kind of the whole idea. Transformations are all three of those types, versus translation is just one of the types. So, translation again moves every point the same distance in the same direction, and you can think of this as a slide. So we're sliding the function up or down, or left or right. Alright, so if we refer to y equals mx plus b, if b increases, you're going up, and if b decreases, you're going down. So from here you can see this was our parent function, and then if we do minus 2, notice it's going down on the axis. If we do plus 3, notice it's going up on the axis. Alright, so we're going to do an example to kind of see how this works. So we're going to graph the function 2x, and we're going to graph the function 2x minus 6, and describe the transformation from the graph. So hopefully you can notice that one of them is just 2x, and the other is 2x minus 6. So that does mean that the minus 6 is the thing that's transforming, and as we kind of looked at over here, if b decreases, because we're going to minus 6, it will be moving down. So we can kind of identify that it's going down 6 units before we even graph it, because we see that difference. Alright, so to graph here we've got 2x. So remember that means that if we identify the b value in here, our b value is 0. I'm going to do it this way. So that means that our slope is 2, but technically it's 2 over 1, which means we'll rise 2. Oh, I just wrote right. So we rise 2 and we run right 1. And then your intercept is going to be at a b of 0. So if we graph, we're starting at 0, and then we're going to go rise 2 and run 1. Rise 2, run 1, etc., etc. Alright, and the next one, so we've got 2x minus 6, that means that our slope is 2. So again, slope is 2 over 1, where we rise 2, run 1, and then our b is 6, or well, negative 6 actually. So that means we'll start at negative 6, and then we'll go up 2 over 1, up 2 over 1, etc. And so hopefully you can see that that went down 6 units from being the green one to being the blue. Alright. So the description again, it's shifted down 6 units. Alright. Here's a visual where they graphed it. You can see it on the calculator, how it goes down. You can see it on their graph, how it goes down. Just kind of a more exact version of what I just did. Just easier to look at. Alright, and then we have our rotation, and your rotation happens about a point, so it's kind of like putting your finger here, and then you spin the arms there. Alright, and so we're going to think of a transformation as about a point, and you can think of it as a turn, and the y-intercepts are the same, but the slopes are different. So that y-intercept is kind of that point of where it's turning, and then from there you're rotating. We refer to y equals mx plus b because the slope is changed. It causes a rotation, but it's still about the 0b. And so the larger the slope, the steeper the line. Don't forget about that. Even if the slope is negative versus positive, it's still going to be steep, just in the downward direction. Alright, so we're going to do an example of rotating a linear function. So if we take the time to rotate, let's see, our first equation is f of x equals x, very much a parent function, because our slope is not necessarily pictured, and neither is our b, but that means the slope is still just 1 over 1, and that the intercept is 0. So intercept is 0, just going through the axis here, right there in the center of the origin. Alright, but then we're going to have 5x, so g of x equals 5x, in association with mx plus b, means that our slope is now 5, but over 1, and our intercept is still 0. So it's still going through 0, 0, but then it's going to rise 5 and run 1, and rise 5 and run 1. So hopefully you can see that that is very much more vertical than the next one. So it has rotated to the left there, about the origin. So our description of this is going to be it's steeper. G of x is steeper than f of x. And we can also talk about how it's rotated about 0, 0. And you can even be super specific and say that it rotates counterclockwise. Imagining the hands on a clock, if it was moving this way, that would be counter to what it should be doing. And so that's where that counterclockwise comes from. Again, kind of looking at a nicer picture than mine. Here's what it would look like on the calculator if you graph the original function here, and then the new function, or the child function versus parent, and then the same thing kind of over here. Alright, then we move on to our third type of transformation, which is reflection. And a reflection reflects an image over a line, in this case across the y-axis, so this one here. It can actually rotate about any line, even the x-axis, doesn't really matter, but of course, as long as it did reflect, that's going to be a reflection. So you do need to change the sign of the slope. So this one here most likely has a positive slope, this one here has a negative slope, and so since they are reflected and looking very much the same, that means that they're just going to be the opposite of each other, not necessarily the flip. Alright, so the next one here, they want you to take f of x, which is 2x plus 2, and reflect it across the y-axis. So if f of x equals 2x plus 2, that means that our slope is 2 and our intercept is b. So if our slope is 2, it's 2 over 1, and our intercept is 2, meaning 0, 2. So we start at 2, and then we move our slope. It does go backwards in that same direction as well, so it makes a straight line. And so that's our original function, f of x, but now they want us to make g of x, which is across the y-axis. So here's the y-axis that I'm going to use as my mirror. And then I'm going to graph. So of course it's going to have to meet the mirror here. And then if we kind of just assume its reflection, it is going to have to go up in that same kind of rate. So we're going to go back 1 up 2, back 1 up 2. And so then it is going to be like an equal distance from that reflection line for across at 10. And then of course the same thing happens going down as well. Oops, that was not a point. There. And so that one we will call g of x, g of x. Alright, we also want to write a function to describe that. So g of x, whoops. We just said intercepts at 2, just like the other one, so our b equals 2. And then our slope, we kind of talked about it in its reflection idea, but it does go down 2 over 1. So that's going to mean negative 2 over 1, or just negative 2. And so taking a look at how it changes, this used to be positive, and now this is negative, and so that's the only difference that happens there. Alright, so that is our equation. And this again is kind of a better version of that, to kind of see what's happening. Alright, so there is technically a quiz here to just kind of see what happens to these. So if we take a look at the first one and describe the transformation, we're trying to describe, is it a translation, is it a reflection, or the other one. Why am I forgetting that one? Yep, a rotation there. That's what it was. A translation, a rotation, or a reflection. Alright, so on that note, let's see. The only difference here is not that it's adding a number or subtracting a number or making a slope negative, and so this is going to be a rotation. If you can kind of imagine, g of x is from the graph of f of x to g of x. Okay, so f of x is actually going to be this one here, and g of x would be this one here. And so we're rotating clockwise. And we're going to want to say it's on 0, 0, because it would have been at that axis. Alright, the next one here, imagining what's happening, they've got the same slope, but now instead of an intercept at -1, it's now at 6. And so that means that it's going to be a translation. And it's actually up 7 units or squares or pieces. Alright, the next one, we have a 1/5 slope and a 2. So if we imagine what a 1/5 slope is, a 1/5 slope is up 1 over 5, so it's a little bit more horizontal, versus a up 2 over 1, which we just did, is more of a vertical. And so to get from one to the other, to get from f of x to g of x, we end up going counterclockwise around the origin, because they both have the same intercept here. So we're going to say it's a rotation, counterclockwise, on 0, 0. And let's see, last one on this page, we've got 5x to -5x. We just talked about that, so that one's going to be a reflection. on the point that they both share, which is 0, 0. On that, oh yeah, that's not really what I meant. I meant on the y-axis. Again, because the first one, f of x would be going up, and g of x would be going down, and they would both meet at that origin in very steep manners, steep slope. Alright, the next ones, we've got the parent function here. They're saying how does it get from x to x minus 4? Well, this used to be 0, and now it's minus 4, so this would be a translation. And it turns out we go down 4 units. And then the last one of this type, we've got negative 3x, and now negative 1x, and then plus 1. So I think there's two things happening here. So the slope going from negative 3 to negative 1 means that it's going to rotate counterclockwise. And then this 0 to a 1 means that it also translates up 1 unit. Whoops. So it's going to rotate a little bit counterclockwise and then also be shifted up. Alright, so this last one here, a little word problem. A cashier gets a $50 bonus for working on a holiday plus $9 per hour. Alright, the total holiday salary is given by the function. Hey, so here's the 9 for 9 per hour and the 50 plus the additional bonus. So that's what that is. How will the graph change if the bonus is raised to $75? So we would replace 50 with 75. So that first question means that if 50 becomes 75, it goes up 25 units. If the hourly rate is raised to 12, that means that it's now a steeper line. So instead of being at 9, it's actually at 12, so it's more steep. And so that means a rotation, I'll identify what it was, 9 to 12 is a rotation counterclockwise. Because again, we were slightly steep, but then got steeper, so counterclockwise. Alright, there you go. So that is our notes for this section. Kind of a lot, but also hopefully you have seen things shifting up and down, and so now we just have the names for them.